Scene script. Have you ever wondered if it's possible to travel faster than light? What if we told you mathematically we might have just broken Einstein's cosmic speed limit? For over a century, Einstein's theory of special relativity has held sway, dictating that nothing can surpass the speed of light. This universal speed limit, clocking in at a brisk 300,000 kilometers per second, has long been considered the ultimate boundary, the edge of what's possible. But what if it's not? Enter two intrepid mathematicians, James Hill and Barry Cox, from the University of Adelaide in Australia. These two have dared to dream beyond Einstein, not by challenging his theory, but by extending it. They've developed new formulas, new mathematical equations that theoretically allow for speeds beyond the speed of light. Dr. Cox, one of the authors of this groundbreaking research, puts it this way: "We are mathematicians, not physicists, so we approach the problem from a mathematical theoretical perspective." They're not suggesting how one might achieve such blistering speeds, but rather, they're providing the mathematical framework to understand it if it were to occur. So, if some bold explorer of the cosmos were to devise a method to travel faster than light, they could now have a mathematical speedometer to guide them. An exciting proposition, isn't it? But let's be clear. Hill and Cox aren't contradicting Einstein. They're not challenging the theory of relativity. Instead, they're presenting it with a new facet, a new dimension. They're expanding the realm of what's possible, pushing the boundaries of our understanding. Even Einstein, despite the enormous success of his theory, never liked setting limits on the universe. So perhaps he would have appreciated this endeavor. The scientific community, always eager for new frontiers, has long speculated about exceeding the speed of light. And now, thanks to the work of Hill and Cox, we have a mathematical foundation to explore this tantalizing possibility. So it seems the speed of light might not be the ultimate limit after all. Einstein's theory of relativity has been dominant for over a century, but could it be due for an update? In the simplest terms, Einstein's special theory of relativity, published in 1905, tells us that motion and speed are always relative to the observer's frame of reference. It connects measurements of the same physical event when viewed from different points, and this connection depends on the relative velocity of the two observers. In essence, it's all about perspective. Consider this. If you're sitting in a moving train and you toss a ball up in the air, to you, the ball goes straight up and comes straight back down. But to someone outside the train watching you, the ball takes a curved path. Neither of you is wrong. You simply have different perspectives. According to this theory, nothing can move faster than the speed of light. This is a universal speed limit, a line drawn in the cosmic sand, if you will. But what if we could cross that line? Enter James Hill and Barry Cox, mathematicians from the University of Adelaide in Australia. They've developed new formulas that, theoretically, allow for movement beyond the speed of light. "We are mathematicians, not physicists," Dr. Cox explains, "so we approach the problem from a mathematical theoretical perspective." Their work doesn't explain how to actually achieve these speeds, only how the equations of motion should operate in such scenarios. The fascinating part is, their theory doesn't contradict Einstein's. Instead, it provides a new facet, a fresh perspective. Their formulas extend special relativity to situations where relative velocity could be infinite, allowing them to describe motion at speeds faster than light, known as superluminal speeds. An intriguing notion, isn't it? This doesn't mean we'll be zipping around the universe at warp speed anytime soon, but it does open up new realms of possibility, new areas of exploration. Einstein's theory might not be contradicted, but it is certainly being expanded upon. Our universe is vast and full of mysteries, and one of those mysteries might just be the ability to travel faster than light. Despite the massive success of Einstein's theory of relativity, it has always been somewhat of a thorn in the side of physicists. The theory, as brilliant as it is, does set certain limitations, one of which is that nothing can move faster than the speed of light. But physicists, being the curious beings that they are, have never been comfortable with setting limits on anything in the universe. And so, speculation about exceeding the speed of light has been a hot topic for quite some time. A few months back, the scientific community was thrown into a frenzy when an experiment seemed to suggest that neutrinos might have traveled faster than light. Yes, you heard it right! Faster than light. But before you get too excited, it's important to note that this was later found to be due to defects in the experiment itself, not some groundbreaking discovery that defied the laws of physics. However, this incident did lead to some interesting conversations and reflections among scientists. It forced them to reconsider the speed limit set by Einstein's theory. What if, just what if, there was a way to break this speed limit? What would the equations look like then? These were some of the questions that began to buzz around scientific circles, stirring up a sense of excitement and curiosity. Enter Dr. James Hill and Dr. Barry Cox, two mathematicians from the University of Adelaide in Australia. Instead of being deterred by the speed limit set by Einstein's theory, they saw it as a challenge and started working on new formulas that would allow for travel beyond the speed of light. But it's important to remember that these formulas are purely mathematical at the moment. They don't provide a practical way to travel faster than light, at least not yet. However, they do open up new possibilities and give us a whole new perspective on the universe and its workings. So, who knows? Maybe in the future, we'll be able to travel to distant galaxies in the blink of an eye. When it comes to the universe, perhaps we should never say never. The special theory of relativity is complex, but at its core, it's all about how we perceive motion and speed. This theory, introduced to the world by Albert Einstein in 1905, revolves around the idea of relativity, the concept that motion and speed are not absolute, but always relative to the observer's frame of reference. Imagine you're watching a ball game. You're sitting in the stands and your friend is on the field. You both see a ball being thrown, but you perceive its speed differently. While you might see the ball traveling at a certain speed, your friend on the field, who is moving relative to the ball, might see it moving slower or faster. That's relativity in its simplest form. Einstein's theory takes this concept and applies it to the entire universe. It suggests that measurements of the same physical event, like the speed of a star or the path of a comet, can vary when viewed from different points. This variation depends on the relative velocity of the two observers. But what if we could move at speeds faster than light, the universal speed limit according to Einstein? That's where the work of James Hill and Barry Cox comes into play. These two mathematicians have developed new formulas that extend special relativity to situations where relative velocity can be infinite. This means they could potentially describe motion at superluminal speeds, speeds faster than light. Remember, this isn't about dismantling Einstein's theory, rather it's about expanding it, adding a new facet to our understanding of the universe. It's a mathematical extension that doesn't rely on imaginary numbers or complex physics, just pure, elegant mathematics. So what does this mean for us? Well, if someone ever figures out a way to travel faster than light, we now have the equations to track their journey. We have a reliable speedometer for the intrepid traveler moving beyond the boundaries of light speed. Relativity is all about perspective, and perhaps it's time our perspective expanded beyond the speed of light. Imagine being able to travel at speeds faster than light. Sounds like science fiction, right? But it may just be a mathematical reality. Now let's dive deeper into this fascinating concept of superluminal speeds. It's a term that might sound like it's straight out of a sci-fi novel, but in fact, it's firmly rooted in the world of theoretical physics. Simply put, superluminal speeds refer to velocities that exceed the speed of light. The basis for this concept comes from the work of James Hill and Barry Cox, two mathematicians from the University of Adelaide in Australia. What they've done is quite extraordinary. They've developed new formulas that extend Einstein's special theory of relativity to accommodate situations where relative velocity can be infinite, a feat that, until now, was thought to be impossible. Their work doesn't contradict Einstein's theory, but rather, it expands upon it. Remember, Einstein's theory itself was a revolutionary concept when it was first introduced in 1905. It changed our understanding of motion and speed, stating that these are always relative to the observer's frame of reference. What Hill and Cox have done is to extend this theory even further. Their formulas allow for the description of motion at speeds faster than light, bringing the concept of superluminal speeds from the realm of science fiction to the edge of scientific possibility. They approach this problem from a purely mathematical perspective, without getting entangled in the complexities of physics. The result is a natural and logical extension of Einstein's theory, without the need for imaginary numbers or intricate physics. This mathematical breakthrough doesn't mean we'll be boarding intergalactic spaceships anytime soon, but it does open up a whole new field of theoretical exploration. It gives us a foundation to start imagining and potentially planning for a future where the speed of light is not the ultimate speed limit. Who knows, maybe one day we'll look back and wonder how we ever thought the speed of light was the fastest we could go.